8, which are the sections on transformations, which is the boxes, right? Draw a function, inverse, and function composition. Those concepts always are there in mathematics, no matter which course you take, so you really need to know those. For our chapter 2, we need to know how to deal with complex numbers, right? Knowing the definition that I is defined as the square root of -1. We also need to be able to work with quadratic function, where we focus on f of x being a times x minus h squared plus k, where vertex is h comma k. Lines of symmetry goes through h. Line of symmetry is, in this case, x equals h. What else do we need to focus on? Domain, always from -infinity to infinity for polynomials. We also need to focus on zeros, which are also known as roots, x-intercepts, and so on. Those are all different names for the same concept. We want to focus on asymptotes. And for those, we have vertical asymptote, horizontal asymptote, and slant asymptote. Each one of those has the rule of how to find it. And finally, graphing rational equation, rational function. Here in blue, 1.6 transformation, 1.7 function composition, and 1.8 inverse functions. So this discussion now is on asymptotes. These are extremely important concepts: horizontal, vertical, and slant. We'll start with vertical first. So vertical asymptote is going to be this vertical line that goes through a value, obviously, on the x-axis. So in this case, it will be x equals to c. It cannot be crossed, it cannot be pierced through. So vertical asymptotes are always strong. How do we find it? Well, for now, we set denominator equal to 0. That's how we find the vertical asymptotes. Then you solve the equation. I will write in red. Watch for cancellations. It's very important. So, if I have f of x equal to 3 over x squared minus 100, I take this denominator, x squared minus 100, set it equal to 0, and from there get that x is equal to positive or negative 10. These are your vertical asymptotes. vertical asymptotes are also breaks in the domain. So the domain for this polynomial would be from negative infinity, for this function, would be from negative infinity to -1, from negative 10, then negative 10 to positive 10, and then positive 10 all the way to positive infinity. So these vertical asymptotes are also breaks in the domain. And that's it for vertical asymptotes. Horizontal. So for horizontal asymptote is going to be a horizontal line somewhere on the grid, and that one will always have a y equals a number, where this one was x equals a number, whatever number, we'll see. So now that we have this horizontal asymptote, we are going to memorize 3 rules that will tell us what kind of where the asymptote is. So if you have ax to the p over bx to the q, and then there is some blah whatever, those are the leading terms, it can go one of the 3 ways. P larger than q, no horizontal asymptote. P equal to q, horizontal asymptote is at the ratio of a over b, which are the coefficients of leading term. And then p could be less than q, and for p less than q, we have horizontal asymptote at 0. So if the larger exponent is in denominator, asymptote is 0. Larger exponent in the numerator, no horizontal asymptote. And if the exponents are the same, we get the ratio of front coefficients, so a over b. Bueno? Slant asymptote. So we didn't get in class to talk much about this one, but that one is the special case right there. So slant asymptote happens when you have this ax to the p plus whatever stuff, plus that over bxq plus whatever the stuff, when you have that p is equal to q plus 1. So when the degree in the numerator is exactly by 1 larger than the degree in the denominator, you will have the slant asymptote, and you find it through long division. So an example of that would be, let's say you have y equals x squared minus 3x plus 1 divided by x plus 2. The degree in the numerator, which is squared, is by 1 larger than the degree in the denominator, which is 1. So now we can do long division. Well, in this case, we can do synthetic as well, but long division works all the time. So you can use the long division process to find where the asymptote is. So that will be x plus 2 divided into x squared minus 3x plus 1. So x goes into x squared x times, multiply it back, which is x squared plus 2x. Subtract it, we get negative 5x, and then plus 1, minus 5. And then when you multiply back, you get minus 5x minus 10. When you subtract that, you will get 11. So that's the remainder. We don't care about the remainder because look what you have here on top. You already have y equal mx plus b. We know that all asymptotes are straight lines. Therefore, the requirement that the numerator degree has to be exactly by 1 larger than the denominator degree. So in this case, slant asymptote is at y equals x minus 5. Horizontal asymptote, none, because the numerator has the greater exponent. And then the vertical asymptote is clearly at negative 2. So you can quickly draw this, right? You have negative 2. And then you have your x minus 5, so negative 5 on y-axis. And then you go at 45 degrees because that's what the slope is. And as you can see, these two asymptotes that you have, a slant asymptote and a vertical asymptote, partition the space into 4 regions, and then you can have to figure out where this function is. So that's the overview of asymptotes. You have 3 different kinds. Vertical asymptotes set denominator equal to 0. Horizontal asymptotes are making you memorize the 3 rules. And the slant asymptote only exists if the numerator exponent is by 1 larger than the exponent in the denominator, which means that you can do long division and you will get a linear line which you can graph, and that is your asymptote, slant asymptote. You can never have horizontal and slant asymptote at the same time because by definition slant asymptote is obtained from the problems where the degree in the numerator is by 1 larger than the degree in the denominator, so exactly by 1. And then you have the rule for horizontal asymptotes which says that if the degree in the numerator is smaller than the degree in the denominator, the asymptote is 0, but if it's larger, it's infinity. And that's it. That's the story of asymptotes. Yes?
How did you get the vertical asymptote?
I said denominator equal to 0, so x plus 2 equals 0. Right?
Why is it on the right side?
Oh, yeah, you're right. I wrote it right. I didn't graph it right. I graphed the vertical asymptote on the right through positive 2 instead of through negative 2. Very good catch. Qualify for 3 points for paying attention.
So we still go to the right side like that, so it's still, you know,
What do you mean go to the right side?
we're on the right side of the y-axis, we just continue on, it still satisfies going to...
Goes forever.
Okay, gotcha.
Asymptotes would extend forever in those directions.
We're a slight little bit out.
Is it?
The other way, yeah. Yeah, yeah.
No? I'm not.
Why is there 11 is there? Are you not going to write it down?
I don't need to write anything down regarding this one because this is all I need. It's a linear line to graph.
Oh, okay.
The remainder has nothing to do with it. In this case. There is going to be a problem on the exam where you will have to use rational zero theorem, right, to figure out possible zeros and then use the remainder theorem to find which one gives you zero remainder, which means it's a root, which then you can do synthetic division and all that kind of stuff. There is going to be a problem like that. I'm not going to bother with mean value theorem and stuff. We have enough of that in calculus. Definitely graphing functions, graphing rational function, definitely. You know, finding all of the domain and x-intercept, y-intercept, stuff we did in 2.6. So definitely a graphing problem, definitely the one that you are supposed to factor it completely. I might put in one of those problems where you have to find the polynomial when you ask. Something like that. Because that's, let me just, if you guys forgot, or you haven't gotten to the homework, so you didn't run into it yet, this one. Where you look for polynomial, you're given roots. You are supposed to know that if you have one complex root, the complex conjugate, which is its pair, is also on the list. And then write those roots as factors, and then multiply them out, and then obtain the polynomial. So you can't see the polynomial yet. Here it comes. There we go. So this is the polynomial in black over here, which we obtained by foiling and canceling terms and so on. And then you need to make it go to this point. And the way to make this polynomial go to that point is to stretch it, and you stretch it by multiplying a constant in front. That is from 1.6 idea. So now you will plug your 2's for each x, you will plug your 91 on this side, and you will be able to compute the value for a. Yes?
We're given x equals -5, and so we need to find what?
A polynomial. Yeah, these are the roots of a polynomial that we want to find. And that's how I create your problem. This is what I use. I say I want the roots to be 2, 7, and -140. And what do I do with that? I just make the factors and I FOIL it out and I say here. And then you go and you just do the rational root and keep checking through the list until you run into a number that works. Cheers. No, not a of 91. That's like a times 91. Because this top in parentheses turned out to be 91. Maybe if I write it as 91 times a, and then I go divide by 91, divide by 91 would make more sense.
So how did we?
This is 91 right here.
Yeah, I know that's 91.
So 91 times a is 91, divide both sides by 91, and a is 1.
So you're not going to give us a on the thing, right? You found the same format as that one.
Yeah, it's going to be identical format like this one if that problem pops up.
What about the first one you were saying when it was, getting synthetic division, finding rational variables?
That's exactly the one that you asked me like 5 times.
Oh, really? That's not okay.
So you use the rational zeros, you figure out what are the candidates, you use the rational zeros, the remainder theorem to figure out which one is the root, and synthetic division. Rinse and repeat, rinse and repeat.
Okay, I can do that.
Oh, it's fun. What else would you do? Look at this disgusting weather outside.
Yeah, it is a little chilly out there.
How do you find your y-intercept with this? When you can x squared.
Makes you want to buy math.
I'm still on fire.
There's only like 5 weeks left.
Very quickly because
Is it very quickly?
only 5 sections left.
What?
5 sections left.
So, do you think it will be out?
That.
All right, let me just ask, are there any questions regarding this exam before I shut down the stream and end the video? Yeah, this is all online, yes. You good? All right, any other questions regarding exam? All right.